In another tutorial, I was connecting several, that is, a couple of type K thermocouples to an Arduino. And I was using two MAX6675 modules you can get on eBay or AliExpress or Banggood, wherever. And yeah, I got very much in the details there, and yeah, the software, the latest software version I developed in that tutorial actually used the SPI data bus of the Arduino, which the standard library, which comes in the Arduino environment for the MAX6675, does not. Yeah, oh, sorry, card link. However, I also pointed out a little caveat when using these little thermocouples, and that is if you have more of them connected, yeah, to your same power supply, they are not galvanically isolated. So I'm reading here 6 ohms, and you can see I have the temperatures displayed here in the back. Something interesting happens. Yeah, I have erroneous readings caused by the voltage injected into the system by my own meter here. And I want to solve that issue. That is, the goal will be to galvanically isolate these two sensors from each other. And not on the analog side. That would be, it's possible, but that would be quite a trick. No, we'll try to galvanically isolate the digital side, the SPI bus side of the MAX, sorry, switching that off, of the MAX6675s to the Arduino. So if we look at the schematic that I already showed in that other tutorial, I have here my SPI bus. So I have black my clock line from the Arduino, which goes to each of my slaves. That is the MAX6675 module. And I have in red the master in slave out line that goes from both slaves to my master, the Arduino. And of course, for each slave I have a different chip select line. So let's assume I want to galvanically isolate that slave here. So I need to somehow isolate these 3 signal lines, yeah. Slave out, master in, obviously going in that direction. Chip select is obviously going in, and my clock is also going in. In addition, I will have to provide, of course, somehow another power supply for my slave. I mean, doesn't make any sense to just isolate your digital data lines and yeah, still use the same power as the Arduino. Now you could try building something here with optocouplers and a lot of other support ICs, but fortunately you don't have to. There are things called digital isolators, and I have here the schematic of Silicon Labs 8631, which incidentally gives you 2 isolated digital channels in one direction and another one in the other direction. So it's quite simple to use one channel for our clock line from the Arduino, or more general the SPI bus, to our MAX6675 or to our SPI slave, another line with the chip select to our slave, and the slave out goes in this direction to our master in slave out in the Arduino. Quite simple. And these things are really neat. They do everything. Yeah, they even have Schmidt trigger inputs. So yeah, and the isolation in that type of chip is actually established by sending an RF signal, yeah, over the isolation gap. So you have here a little radio frequency transmitter and here a radio frequency transceiver. Yeah, I mentioned optocouplers. A problem with optocouplers is that most of them are slow. That thing supports up to 1 megabit per second. Yeah, you first have to find an optocoupler, yeah, with Schmidt trigger in, Schmidt trigger out, etc. that can do that. In addition, because we have here a bus, the SPI bus, we need a mechanism to pull the meso line on high impedance. Yeah, you remember all slaves are, when they are selected by chip select low, are writing to that meso line, to your SPI master or Arduino in our case. And of course, if a slave is not selected, it pulls the output into a high impedance state. So neither low nor high, but high impedance. So it won't interfere with the meso line of the bus, while another slave is actually putting out here a high or low signal. And if you use a digital isolator, and the SI8631 can do that, of course, you need a model that can also pull an output to high impedance. In this case, this is done via an enable pin. On that side you have also an enable pin for the outputs, but there's only one other chip here, our MAX6675, so we don't need to control that. We can leave the enable on that side simply on high, or I guess it has a pull-up resistor. You can leave that pin simply open. It would work fine, and the outputs are enabled to deliver you a low or high signal. But on that side, we need to control our meso output gate here. And chip select on an SPI bus is usually inverted, so it's active low. So we need to invert that signal here into the enable pin, because the enable pin is active high. So as soon as you select the slave on that side and you pull the chip select line low, our enable pin goes high and therefore drives our meso line high or low, depending on the slave out signal coming in here. So and that's all. These are really nice tiny chips. They are not that expensive and they do everything you need. One remark, we are missing, of course, here one additional data line, and that would also go in this direction here, and that's the master out, slave in. But there is another SI8675 model available, which has, of course, 3 lines in this direction and 1 line in that direction. That would be only a little extension if you really have an SPI slave who is able to communicate in both directions. Okay, let's update our schematic here accordingly. So I zoomed in a little bit. The nano is up here somewhere. Yeah, we have still our unisolated MAX6675, and now we have here our isolated MAX6675, which needs, of course, 5-volt isolated and an isolated ground, so different power supply. We will see how we do that. Yeah, that one is still running on the 5 volts supplied of the Arduino and of the Arduino ground. Now, here is our digital isolator, and yeah, we looked already at the details. So S clock is going in, MISO is going out with an enable. And yeah, I don't have an inverter chip handy, so I will just provide the chip select and an inverted, not chip select, from the Arduino. And yeah, for the code, I mean, we don't have to review that in code. Also look into the previous tutorial. Yeah, and on that side, we simply connect 1 to 1. So as clock is going through, chip select is going through, and slave out is going through to our SPI bus. And that's all. Let's build it on the breadboard and try if that works. So what's on the breadboard now? I have, of course, still my Arduino here, which is supplying 1 power rail, and that power rail is supplying my first unisolated MAX6675, and it's providing one side of the digital isolator with power. Yeah, my SPI bus, yeah, clock and slave out, white and orange, yeah, goes to the first max and then to the digital isolator. My second, now galvanically isolated max, gets its SPI bus signals from the digital isolator and is powered from a, yeah, that's off-board my bench power supply, from a second galvanically isolated from the Arduino power source. It's power, and yeah, the same power source is powering the other side of the digital isolator. And I don't know if you can see it, that was not in the circuit diagram. There are 2 100 nanofarad capacitors, decoupling capacitors for both power pins on both sides of the digital isolator. Yeah, something that's in the fine print of the datasheet. Yeah, it just wants these thingies, and that's okay. But is it working? And it seems it does work. On the graph you see the blue line and the red line. Red line is the isolated, now galvanically isolated thermocouple. Blue line is the unisolated one. And if I heat up the unisolated one, yeah, you can see temperatures rising very nicely. And if I heat up the isolated one, let's see. Yeah, temperature is rising there too. So no problems at all. Can I have another degree maybe? Oh, yeah, thank you. So that's good, but did that solve our initial problem? We can test that right now. So temperature is back to normal level, 23, 24 degrees Celsius. Yeah, there in the back you see my bench power supply providing the isolated side with 5 volts. And here I have my cheapest multimeter on yeah, contact range. And if I connect them now to both of the thermocouples, nothing happens. And the temperature reading is also still correct. So yeah, both thermocouples are of course now warming up a little bit, but yeah, I guess you can see that the whole shebang is not one going up and one going down. So yeah, success. There is one little issue left here. I mean, if you put that on a circuit board, you don't want to have to supply or use a bench power supply to power your isolated site. So we need a solution there. And the solution to replace this, or in general some other power supply from a battery or whatever, I mean, of course you cannot use a same USB ground and build something around that, is this. An isolated, unregulated DC-DC converter. We can use unregulated DC-DC converter because we already have a regulated 5-volt rail, and within reason, yeah, this will work. For details, see another tutorial, card link, especially about these thingies. What I have here in my hand is not really suitable for the job, so I will have to add some additional parts to make it work. Yeah, guesstimate we are sucking out here yeah, the secondary side of our digital isolator and the MAX chip, yeah, sub 10 milliamps, and I need to suck out of that sucker. Okay, too much sucking. At least 20 milliamps for it to really run stable. Anyway, I update the schematics and then we have a look at it. So nothing much changed, but for this new part. That's the isolated DC-DC converter. And yeah, for space reasons, I renamed 5-volt isolated to 5-volt ISO. The primary side of that DC-DC converter is of course powered by our Arduino 5-volt power rail. Yeah, like our non-isolated MAX module here. And the secondary side is powering all the isolated stuff here. So the other half of the digital isolator as well as our isolated MAX6675 module. Yeah, as I said, for details, see the other tutorial, but now you can see that we have here a nice isolated area. So these isolated DC-DC converters really establish a galvanic isolation between the input side and the output side. Yeah, some additional elements here, a little bit bigger cap here on the input side because there's a lot of current ripple. This is of course working in switch mode. And on the output side also a little filter capacitor, yeah, just to keep the noise down. And later on the breadboard you will also find that I added here a little load resistor because, as I mentioned before, this thing has too much power for the little current demand on that side, and since it's unregulated, its output voltage would be too high for a normal 5-volt rail. Now let's have a look at the breadboard. Not much to see here. Yeah, my 5-volt rail from the Arduino is now also going into that DC-DC converter here. There's the input capacitor and the output pins. Yeah, you see the little filter capacitor at the output and the load resistor. The output pins are feeding into the power supply of the secondary side of the isolator and the MAX module. Only question left, does it work? And indeed it does. And we still have, yeah, still using the GP multimeter, still isolation between our two. And yeah, just heating up the blue one, number one. So yeah, the red one, our isolated one, should come down now, slowly but surely again. Yeah, it does. Yeah, anyway, that principle using digital isolators on an SPI bus is of course not limited to these MAX6675 chips. You can isolate any SPI device on the SPI bus if you have a problem with a high voltage potential on, yeah, the other side of the device. There are also digital isolators available for I2C. These work a little bit more complicated because on the I2C data line, data is going on the same wire in both directions. So they have a little bit more hardware built in than these ones here. In general, you get digital isolators for most bus architectures with the exception of single wire. I don't know about a digital isolator for the single wire stuff, especially when it's not powered but really powered through the data line. If you have any ideas about digital isolators available for that, please leave a comment. Otherwise, that's it for today. Yeah, isolating an SPI device, example Arduino and MAX6675. Bye.